Alfalfa is a high-value crop and a power-packed ingredient in cattle rations, especially for the dairy producer. Yet this crop can add more uncertainty to the ration than any other ingredient. The reason is that alfalfa's relative feed value, or RFV, can vary drastically, affected by the plant variety, maturity at cutting, or any of several handling and harvesting conditions. In fact, it's not uncommon for RFV to range from lows of 100 points to highs of over 250. These wide swings in quality affect the amount of hay needed in the ration, the production potential of that hay, and the cost of added protein and energy needed to balance the ration. Having an accurate RFV measurement is critical for profitability. For alfalfa producers and buyers, the standard practice for gaining some indication of the hay's quality is through random core sampling. It's also commonly understood that two core samples taken from the same bale can be different, and that alfalfa quality can vary greatly from one part of a field to another, or even within the same windrow. Two bales made just minutes apart can often vary 20 to 30 points in RFV. Attempting to know the true RFV of hay being sold and fed is important to all parties in this feed chain.
I believe we need to do a step up to the plate, another notch here to make a better product for our customers, especially the dairy industry. We need to be more consistent in the kind of hay that we haul them, that the load of hay that we haul into the dairy all is about the same relative feed value instead of varying as much as 30 to 40 points on individual bales.
Now, Case IH's ProRFV system has made that a reality with breakthrough technology to accurately determine and record the RFV and TDN of every bale, on the go, right on the baler. It's well known in the industry that bales with greater density contain more leaves. That's because leaves pack much better than stems. And 90% of alfalfa's feed value is in the leaf portion of the plant. A bale with high leaf content has higher feed value and consequently higher density. The leaf-to-stem ratio can be influenced by several factors. Leaves are flat and compress nicely. Bales with more stems will always weigh less. Stems are round and stiff and will not pack together as well.
We all know that the more leaf you can get into that package, that the better the quality of the hay. The leaf is where your best protein is, and that's where your dairy, your milk quality is in the leaf. And so we have always known that the higher the leaf content, the theory is the better the alfalfa. And with that goes bale density as well. Usually your bale weights are up there when you got better leaf retention.
How does it work? The producer will take a windrow sample of the hay just before or after it's cut and send it to a lab. The value is entered into the Case IH's ProRFV system when they're ready to bale. As the baler operates, dual star wheel sensors take hay moisture readings 96 times every 3 seconds and average those readings for measurements within plus or minus 1% accuracy. So we can absolutely know the moisture content for each bale. Next, the baler scale provides bale weight accuracy within 2 percentage points. From the moisture and weight data, the Case IH ProRFV system calculates the dry matter density and the relative feed value of each individual bale.
We took 50 core samples from this one field and we split the samples. Half of them we sent to a lab in Wisconsin and one to a lab here in Colorado. And when the test results came back, there was about a 4.9% difference in the test, which is not too bad comparing labs. But when we got back the test from this project, it was only 2.6.
So, how accurate is the new ProRFV testing system? To answer that question, Utah State University in Logan, Utah completed a study on 3 cuttings of alfalfa during the 2013 season. 542 harvested bales were individually cored at the university's lab and compared to the RFV values calculated by the ProRFV system. Dr. Alan Young concluded that the system seems to work well in the conditions here in Utah and appears to be a practical way to get a reasonable approximation of the quality of the hay as it comes out of the field. This graph shows the comparative results from 108 bales of first cutting alfalfa made in a 2-hour period in one field as part of the Utah State study. It reveals two dynamics. First, it demonstrates that the ProRFV testing system consistently tracks with the core sample analysis that was done for each bale. Secondly, it shows a wide range in relative feed value from 159 to 230 in bales taken just from this one field. This further points out the need for a system that can evaluate every bale. Realizing it would be a significant change for feeders, growers, and hay buyers to accept the calculated RFV instead of lab analysis, the Case IH ProRFV system was tested on 8 farms across 6 different states, with more than 3,000 bales individually cored and analyzed. The research was done with baling in different temperatures, varieties, and cuttings. It included both irrigated and non-irrigated fields, along with different makes of balers and bale sizes. This graph illustrates the comparative results of the extensive testing. Once again, you can see that the values measured by the ProRFV testing system closely follow the values from the lab coring analysis. This graph plots all 3,000 bales tested, showing a wide range of RFV values. During the baling process, the ProRFV processor displays RFV on the monitor screen and writes each bale's RFV and TDN to a job record that can later be printed out and will also show an average for that job or field. The best way to use these precision RFV values is to apply an electronically readable tag to each bale. The Case IH ProRFV system accomplishes that with its Bale Tagger, which applies a vinyl tag containing an RFID chip to the twine on the bale. The tagger system writes information to the tag, including bale moisture, weight, and relative feed value. It also records the time the bale was made, field location, and more. This recorded data can be read back with either a handheld scanner or one that mounts directly to bale handling machines. Some farms using the system scan the bales as they come out of the field, sorting them by RFV into low, medium, and high-quality groups. Sorting can also be done when the hay is stacked for feeding or as a truck is loaded. This way, hay producers and sellers can give the buyer precisely what he wants. The Case IH portal scanner will scan bales by the incoming or outgoing load, reading the data directly into a computer. This allows for sorting hay loads easily and keeping track of inventory. According to Dr. Young, who conducted the study at Utah State, the advantage in identifying the RFV is significant, especially for dairy producers. He states that sorting and feeding hay according to its quality allows for ration adjustments in order to keep milk production consistent without unknowingly under- or overfeeding metabolizable protein and metabolizable energy. Dr. Young goes on to say, there are potential cost savings by feeding what the cow needs rather than giving her a roller coaster diet. Lower quality hay can be fed to dry cows or heifers. Feeding the high quality hay to high producing cows and not underfeeding them with lower quality alfalfa can translate to a daily increase of nearly 4 pounds of milk per cow, said Dr. Young.
We can sort this hay with our scanner on our stacker and make stacks of quality hay, and we can show the dairymen that we do have a difference here, and the hay that we send them is going to make more milk.
We've been doing some testing over the last year where we're trying to go to the next level and put more information on that tag, which would be the relative feed value added to that tag. Looks like it has a viable option for us to aid us in marketing our hay.
I'm very experienced with hay testing, hay quality. I do about 200 tests per year of dairy quality alfalfa hay. So I'm experienced with tests and have a pretty good knowledge of how actual hay will size up when you test it. We cored 250 bales and the consistency matched right up. The relative feed value from your tag will line up and match with the test that you send into your lab. So it's a win-win for both the farmer and the dairyman that are working in conjunction with each other.
Based on the comprehensive research results, the operators of the test farms are excited about the prospect of using this new system and its calculated RFV values to market their hay. Randomly coring bales to determine RFV is now old technology. The precision farming way to determine and manage hay quality is to measure the whole bale at the time it is produced, tag it that way, ship it that way, and feed it that way. This is a major innovation in production efficiency for the alfalfa producer of tomorrow, and the Case IH ProRFV system will deliver it.